So a couple of you. So the idea with lambda expressions is that they're designed to solve a couple of problems that aren't really problems. Everything they do, you can do other ways. They just allow for a shorthand that allows for some really compact or much more understandable code because it gets a lot of the fluff out of the way. So a good example of when you would use a lambda expression is when you need a callable, i.e. a function, and that function is doing something so simple and so basic that the idea of writing the function seems like too much work. So for example, let's see, a lambda expression that you might say you have a variable a and b equals 3. How do I execute?
Shift enter.
Okay, so if I wanted to do a plus b, right? We all know that's 7. Let's say I wanted a calculator app, and one of my functions is add, right? So normally I would write something like def add ab, and the result would be return a plus b. Okay, that's 2 whole lines of code. But let's say I wanted that function as compact as possible, right? So just for argument's sake, let's say the only thing I care about is minimizing the amount of code I have on screen. So another way of writing that exact same function would be this. Okay, so in a single line of code, I have now made, whoops, I should say add equals. Add equals. Add is now a function, which is a lambda function. Okay, so now I can say add, whoops, where'd I go? Add 4, 3. And I can't type to save my life today, which is okay because I also have a head cold, so I can't talk to save my life today. So it's all good. So it's just another way of writing a function. Now, some caveats with lambdas. First of all, why should you care? There are plenty of places in code where being able to write a simple function for one-time use or used within a loop happens to be handier than writing out your function separately as a function that's callable from all over in your file or in your module. So why should you care? Because there are times where it's handy or where it's practical. It's much simpler than writing it as a separate function. Caveats with lambdas. Everything that the lambda does has to fit in a single expression. So in this case, a plus b is a single expression. Great, I can use that. Expressions can take many forms. And so x equals a if a is greater than b, else b. That's a valid statement, and x will be the greater of a and b, right? So you can have, an expression can have if in it, it can have else in it, it can have function calls in it, it can have all kinds of interesting stuff. But with the lambda, everything in the lambda has to be a single expression. So that's a really quick idea of what a lambda is, a really quick idea of what it can do. But let's talk about the structure of a lambda. And you can see everything you need right there. A lambda, and you also the other thing, remember before when I typed lambda, a comma b, a plus b. The return type of a lambda is a function, right? So it is creating a function for you. It's a function that follows all the same rules that normal functions follow. You can have any list of parameters you want. You can do whatever you want in it, except like I say, it has to evaluate in a single expression. But it is a function. It can be used anywhere a function can be used. So places that functions can be used. Have any of you used map or filter or reduce? Okay, so a couple of you have seen that. One of the things that map functions need, map is a function that iterates over a bunch of items and calls the same function on every one of them. Lambda expressions are really handy for that. I want to call this expression on everything in this list. I can write it up as a lambda, and my iteration can be something like map lambda. Say I want to add 1 to every number in a list. Lambda x, return x plus 1 for a list that I have called L, which I don't have yet. So we'll see, it doesn't know what L is. So let's say L equals 2, 4, what's 2? I can't type, like I say, 6, 8, 10, if I then, how do I rerun a previous line? Or is it easier just to copy and paste? Okay. Yeah. Whoops. What am I missing? I am missing print. Oh, doing something wrong. Well, that would change that. Let's pretend. Let's pretend again that I know what I'm talking about, because sometimes that's a true statement. It is returning a generator. Yes. So this, I'm not going to be able to demonstrate this way, but I could.
You can put the map in a list. Just put out all the results.
So just do a comprehension out of the map.
Or you just say put it in list.
Oh, okay. List that. There we go. So what this did was it took every item in the list and ran whatever function I gave, in this case, the lambda function, on all those items. Right. So if you want to add one to everything in a list, if you want to determine if something is odd or even, if you want to tell, say you have a list of tuples where each tuple has two elements and you want to return the greater of each of them. So I have, maybe you have X and Y coordinates and you want to find all the ones that match some parameter. The lambda expression is just a way to say, right here I need a function, but it's not a complex function. And I don't want to have to go write a function, define it and express it. I just want to express it in place where I'm going to use it. That's what lambdas are good for. So you'll see them used a lot with map, filter, and reduce, which we'll talk about. I'll be talking about that probably in 2 or 3 weeks, or about 2 weeks. You can also use them in comprehensions. They're very handy there. You can also use them pretty much anywhere a callable can go. Say you have a function that takes a function. Has anyone used functions as variables in a function call? A couple of you. Okay. If you need a function that you're passing on to some other function, you can use a lambda in that place. The function I'm passing to this other function is this one, and you can express it very simply. So lambdas are handy when you need to pass a function somewhere, and that function is very, very simple, and you want to express it inline rather than defining it elsewhere. You know, I hadn't thought of that, but that's a grand idea. So what Chalmer just said, sorry, is what about using lambdas in a dictionary where you have maybe a dictionary of functions, and based on you're using it like a lookup table, right? Is that what you're thinking? So based on what I get in parameter A, use the function that I've defined in parameter B, but your functions are all defined inline in the dictionary. So that might look something like this: functions equals. Open, and if I press return, yeah, it's going to do the right thing. Add lambda x with AB x with A plus B, and then I might say mult is lambda AB A times B, and so on. Right now, this is a very readable way of implementing a calculator. I can then have a function that takes an operation and variables, and it just looks up in this table and gets the right lambda to use in that case, and it performs that operation. Right. So they're like I say, they're useful in all kinds of crazy places, but it's all about expressing functions so compactly that, and so obviously, that it doesn't take all the plumbing of writing a full function the traditional way. So how do you write a lambda? Well, you've seen everything you need to see, but I'll expound on that a little bit. A lambda expression always starts with the word lambda and then a parameter list. If you have one parameter, and you can call them whatever you want, they're just variables. So if you have one parameter, you'd list it as a single parameter, and say maybe this would be is instance a integer, int, right? Yeah. This would be a function that returns true if A is an integer and false otherwise. Now you could just call is instance, right? I mean, I'm kind of being ridiculous here, but that's a single parameter lambda. If you had two parameters, you would do the same thing, but with commas separating your parameters. So if you wanted to do 2 parameters, you just list out your parameters on the left of the column. C, D, E. And then you do something with them. A plus B times C minus B modulo E. That's about the most useful lambda you will ever see. No, I'm kidding. That's about the most useless lambda you will ever see. But yeah, you just list you have the word lambda, a list of parameters, a colon, and an expression. The expression doesn't have to use all the parameters, although it should. Otherwise, why do you have them? And it's just, like I say, it's a shorthand for writing functions. Very, very handy for inline functions. If you're familiar with in the C language, the concept of inline functions, or in JavaScript or C# or other languages that take anonymous functions, lambdas are very good in those contexts. They can't be complicated. They can't be multiple lines, but anywhere that you would use an anonymous function or an inline function, lambdas are a prime candidate for that. So there's nothing a lambda does that you can't do by writing a normal function. Normal functions are like the heavyweight way of doing it. Lambdas are just a lightweight way of doing the same thing. But like I say, handy for certain kinds of use cases because it makes everything far more readable because you're getting a lot of the plumbing out of the way and just seeing a raw expression that defines what it is you're doing. Any questions, thoughts, ideas, recommendations for where to get good Thai food? By the way, I love Thai food, so if anyone knows good Thai places, I'm always open to trying new places. Has anyone seen lambdas used in a way and you're wondering what the heck was going on? Oh, since these are functions, you can define them. Like I defined the add functor up here. You can define them like this and use them as functions anywhere in your code. So sometimes at the start of some of my source code files, if I have a bunch of functions that are just really simple operations, I will actually write them as lambdas instead of functions, just at the top of a file. Because again, it's a readability thing. I can glance down and say, oh, obviously, okay, I got it. In 5 lines of code, if I've got 5 functions that are clear and concise and perform some operations. Anything you can do with a function, you can do with a lambda. So you can call it, you can pass it as a variable, you can pass it to something that needs a callable. You can combine lambdas into bigger lambdas. So you can have a lambda expression that is some operation and another lambda expression and a third one that calls A or B, or calls A with including parameters from B or whatever. You can do all kinds of crazy things with them, but everything you can do with a function. They're just synonymous with functions for all uses. And that's a crash course in lambdas.
What's the, can you think of any examples of like crazy lambdas you've seen?
Yes, I have some crazy lambdas. So I just took a course in recommender systems on Coursera, which is a great course and I highly recommend it. And they implemented all of their recommendation systems in Excel. And I was impressed because most people taking the course were not programmers, they were analysts, and so they're used to Excel. So we'll give you Excel spreadsheets that have most of the work templated out for you, and you just fill in the formulas for a couple of places. And I thought, well, I don't want to do that in Excel. I want to do it in Python because Python is my language of choice for anything other than communicating with my girlfriend. And I found my girlfriend does not understand Python. She's non-Pythonic. But so basically a recommender system, really what you're doing are these pretty simple operations, but 7 or 8 levels deep. So I just started writing each operation as a lambda. And I found that I actually completed the entire recommender course without writing a single function the old-fashioned way. The whole thing was done in lambdas. Other than reading the input file off disk, that I didn't have a lambda for that. But once I had the file loaded, it's like, okay, for each item in the file, I just had a comprehension for each item in the file, call this lambda, which kicks off the whole series of all these lambdas in depth. And each lambda by itself correlated with a mathematical expression that was part of the recommender system course. And so I could just map them very easily. Oh, this is this one, this is this one. And it became it was more of, it probably wasn't the cleanest way to write it because these expressions did get kind of long. They were, some of them were 150, 180 characters long on a line. However, it was a test for my own lambda-ness and passed gloriously from the perspective of what can you do with lambdas, and it's not very readable, but it is crazy. Not quite as crazy as the one I learned about this morning, which is if you import, what's the one? If you import, it gives you a poem. No, not a poem. It gives you all the Python.
Import this.
Import this, yes. This is the only thing I've done that is, or found that is more ridiculous than what I did with lambdas in the recommender systems. For those of you who have not done this, if you want a Zen of Python, just say import this, and you get it. And there's probably a lambda for that. There should be. If there isn't, I'll write one. No, but yeah, so crazy things with lambdas. If you're reading out of a math book and everything's expressed as mathematical expressions, that's a prime candidate for lambdas, unless they just get so long that they're not, you know, readable, where multiple lines and an indentation would be helpful. And they are Python language expressions, so they follow all the normal rules. If you have an open parenthesis inside your lambda, you can then spread your expression over multiple lines. But at that point, the question would be, why aren't you writing a function? If it's long enough, you need to put it on multiple lines, you probably want a function. But yeah, just a shorthand way to, and inline functions is probably the way you'll see them the most. So a map expression that needs a function and you just pass that function as a lambda rather than writing the function separately, that's probably the single most common way you'll see them in use in the wild. And when we do map and filter and reduce, we'll be using lambdas for that. So that very reason. And that will be in Python too, so it works the way I expect it to.
Excellent.
So that's all I got. I'm happy to answer questions if you have any, but otherwise I will, yes.
Is there, so I don't know, 2 weeks ago I asked a lambda question. I think this is what maybe systemic from. I actually do have a lambda. I didn't write it. Somebody else wrote it. Is there a way I can like paste it on and you guys can see it, or?
How big is it? Do you want to just read it off and I'll type it in?
It is like probably 7K, but
no, I mean the lambda itself.
Oh, lambda's only. Well, this function that uses the lambda is only like 11 lines, but there's a lot of characters in there.
Can you bring your laptop over here and I'll take a look and see if I can just copy it.
I was in a class and then that's why the question came up and I was like, I don't get this. It's over lambdas and 66.
There's one right here.
Oh, there you go.
79.
Yeah, there's a few.
So do you want an analysis of the whole function, or do you just want an analysis of what the lambda is doing?
Well, I don't know. It's an example that this guy used. I don't know if he's a sans guy. Mark Baggett.
Okay, so the lambda is this: lambda x TCP dot seq. That's the lambda that was just presented. Okay, so what this is doing is it's a lambda that takes, it's a function that takes a single parameter. We're just calling it x in the local context. And it calls, so it's treating x like a dictionary. Or, yeah, dictionary, because TCP is probably not, no. It's probably defined at the top of the file somewhere. Where does TCP come from? That's weird.
These are all the functions at the beginning of the script, so it might be near the end.
Yeah.
Sorted, using sorted to.
Yeah, so if we're trying to find out what TCP is, if TCP is an integer, then X might be a list. Otherwise, X is a dictionary. In either case, X is an item that has indexes, either strings or objects or something, into that reference elements within it. So it's saying for any given X that's passed to it, look up the TCP element within X and then call the .seq, or not call, return the .seq property of that item. So essentially what this is saying is, and then we'll go look at the bigger context and see how it's being used in the context of that whole row.
Almost get
So the lambda is being used as a key to help with sorting. You have a packet stream. It's got the stream of packets that come rolling in. I haven't found what packet stream is. If it's a list or if it's a dictionary, I'm assuming it's some sort of a list of individual packets.
Yeah, and
So
it's if
within that list, you can. That packet is probably a dictionary. You can say,
Yeah.
look at the TCP portion of it, and then look at the sequence.
and actually I know enough about networking that I now see what it's doing and why. But there are some questions that are open. So this is sorted packet stream key equals lambda x TCP dot sequence, and turn that bracket around. So that's what the whole line of code in context says. So sorted, I haven't used sorted with multiple parameters, but I'm guessing I know with sorted, the first item is the thing you want to sort. And the second item is, I guess key is expecting a function or a callable.
It's a key to help with the sorting process. And I'll give you
Okay.
a more simplistic example of a key. Say you have capital letters and lowercase letters.
Mhm.
Lowercase a, lowercase b, capital B. Sorted wants to sort by alphabetical order. So it will put all the capitals together, all the lowercase
So your
together.
key might be is lower.
You could say a key of stir.lower, and it will temporarily make all the things lowercase for the purposes of sorting, but your results still maintain capitalization.
Okay.
So that key is a mechanism to identify how to sort. So
Yeah.
if you get a number back, if you get a comparable back, it then uses that comparable to say, oh, this should go first, that should go second.
Yeah. Now, packets, how many of you know like what goes on the wire when you're doing network communications? Okay, so crash course in networking, overly simplified, but enough to understand this code. When you send a blob of data to a remote machine, if it is small enough, it's sent as a single packet. How big is a packet? It's about anywhere from 2 to 4K. They may have upped packet sizes recently, but when I was doing networking years ago, 4K were big packets. So when you have like an image you're sending that's a megabyte, it's being broken into packets that are 4K. Each of those packets is a subset of the whole, and every packet has a sequence number. So what this is doing is it's saying for every element in packet stream, what we want to do is look up the TCP portion of the packet information. Packets have the IP portion, the TCP portion, they might have an HTML portion, or an HTTP portion. They have they're broken in, they're containers within containers within containers. So this is saying, find the TCP portion and find the sequence number of that portion and use that as the item to sort on. So every packet will have a unique sequence number. So given a stream of packets in some order, put them in order of sequence number. That's basically what this line of code is doing. So I got a packet stream in no particular order, and I'm sorting it into the order that the packets belong in, the way they were originally put together by the sending computer. Because when you receive packets, they don't necessarily come in the order they were sent. You know that packets get routed all over the place, and 2 packets might take a different route. One might get stuck, even if they take the same route, one might get stuck in a buffer somewhere while the other one passes on. So order is not guaranteed. This is reordering them back in the order they were originally sent in. And so key is taking a callable, and in this case, the callable is a lambda expression rather than writing a whole function. It's just, here's a callable that you can use to determine what the sort order for this item is.
So I'll give you a packet that's in your packet stream. Once I have my packet, I will look at the TCP element of that packet. The packet's probably like a dictionary or something. And
then
then
get the
from
sequence.
that, I will take the sequence number.
And use that as the item to sort, use that as the key for sorting. So yep, there's a lambda expression in the wild.
Does this have to be a lambda, or?
It doesn't have to be. It could be you could have a function here. So say you had a function called get sequence number. You would just, your key would be get sequence number.
Can we type that function out?
Sure. So let's say instead you had packet stream. Does that make sense? Def get sequence number, takes a packet, and it returns packet TCP .seq. If you did that, then this expression could be well, that's interesting. This expression needs a callable, but it doesn't have a way to pass parameters to that callable. So you couldn't pass x to it, but this is a function that does the same thing. However, sorted needs a callable. I don't know enough about sorted's key mechanism. Maybe there is a way to pass variable names or items. So actually, I don't know how to do this with a function. I only know how to do this with a lambda.
Probably fake it and it would be reasonable enough.
Yeah, it would look something like.
It would look something like.
Oops. There. Actually, it will work right from what you told me before. So this would be get sequence number. It will work right because this function will be called with each element in packet stream, one at a time. So it can be done as a lambda like that. It can be done as a function where that's the function, and this is how you pass the function. Because the function is going to be, whatever this callable is going to be called with every element in packet stream. So in this case, you're calling a separate function. In this case, you're calling an inline function, but it's the same thing. If that function were complicated, you'd want a function. But if that function really is this simple, it's one single expression, make it a lambda, make it fit in line, and save yourself a few lines of code and wondering where all is this used. Well, it's clear where it's used. It's used right here and only right here. So for a variety of reasons, it makes it more or less readable depending on your coding standards and your reading style and how familiar you are with the language. So does that?
Yeah.
Does that
So
make?
it's a preference still?
There's nowhere where you have to use lambdas that you couldn't use a function instead. You could always use functions. They were added to the language basically for readability, for those simple cases where what you want is so simple, you don't want the infrastructure and the plumbing of a function. And the most common use cases, all the examples you'll see, a lambda is being defined inline where it's going to be used. It's rare that you see someone define a lambda and then later use it. If you're going to do that, there's not much advantage to doing a lambda instead of a function. But so they're very commonly used inline. And in that case, the code becomes so compact that it's obvious what it is, where it's used, and why it's there, as opposed to a function where it's not always obvious. Is it used only here? Is it used elsewhere? You don't have that question in this case. It's obvious that this function is used in one place and one place only. So there is some maintainability advantage there. But you could do it with a function just as easily. And there's no compelling reason to do one or the other, except that I would say from my perspective, this one's more readable because I don't have to go elsewhere to find anything else. It's all in one place.
Kind of along those lines. I mean, if your file is like 1,000 lines long and this is in line 900, but the function is defined on line 10, as soon as you get to this line, you go, oh, get sequence number. I'm not sure what that is. You got to go hunt that thing down, figure out what the function does, blah, blah, blah. And if all it does is basically a dictionary lookup and spit out an item, that's all its job is, the lambda makes a lot of sense. The future use 6 months from now doesn't have to root around to figure out what's happening in there. Yeah. And if you're only ever using this on line 990, then you're not going to use it in like 12 different places. This is perfect, right? Yeah. Saves you trouble in the future, saves the next guy who looks at your code trouble, provided he knows what a lambda is and provided he knows how to use one, right? But.
And there are a lot of people who have never used them or haven't seen them. Just like comprehensions, generators, lambdas, and there's probably a couple other things in the language. Once you learn them, you find uses for them everywhere.
All the time.
Yeah. Who is here for my comprehensions talk, or who has used comprehensions much? So a comprehension is a way of saying, for every item in the list, do this thing. Comprehensions are really, really powerful. You can take 5 or 6 lines of an if-else block and turn it into one line of code. However, if you're not used to reading comprehensions, you'll look at it and go, what the heck? Generators are really powerful. I have this thing I want to do to 1 million items, but I don't want to have all of them in memory as I'm building this list. I want to do them one at a time and spit out intermediate answers and have, so generators are great for not using up a lot of RAM while you're processing a large volume of data. That's not the only thing they're good for, but that's one good thing about them. Lambdas are good for wanting to fit an expression that needs to be in the form of a callable function anywhere in your code. So they're good for that, and they make for very readable code. They can, like anything else, they can be used and abused. But if you know how to use them well, and if you know how to read them, they do give you some advantages in writing code that's more maintainable over time. Doesn't mean they're the end-all answer. There are plenty of cases, like Chalmers said, if you use it in 4 different places, maybe it makes more sense to define it as a function somewhere. But if you're only using it in one place, then it keeps all your code in one place, and you never have the possibility of your code being split up. If you need it to be testable, this is harder to test than a separate function is. If you were trying to write unit tests on your function, that's very easy to do when it's a function. It's harder to do when it's an inline Lambda expression expressed within the middle of some other function call. So you lose something, but if it's so simple that you don't feel like you need to unit test it, it gives you some maintainability advantages. So, any other questions? Cool. That's Lambdas.
Sweet.
And if you're here in 2 weeks, if you're at LCC, if you're wherever we meet in 2 weeks, if you're there, we'll see quite a few Lambdas, because I'll be talking about map and filter and reduce. And it's very common to use Lambdas in those, because you're saying, I want to perform this simple expression on everything in a list. And that list might be 1 million items long. Maybe you have a 5 terabyte file and you're trying to parse through it and extract out a little bit of information from each item. A Lambda is great for that. That along with the map function, which allows you to iterate, and then the filter function, which allows you to say, only find the items that match some condition. Then on those items, do this thing, and then aggregate the data to give me this, maybe you're trying to find an average or standard deviation or something on a very large list of numbers. Map, reduce, and filter are the way you do that, and Lambdas are used throughout because it gives you the simple ways to express the mathematical concepts that you're doing along the way.
So while I was looking at this Jupyter Notebook, I was considering as an option going through and poking around at this Jupyter Notebook, give you guys a sense of what you can do with it. Ria showed a demo of Jupyter Notebooks recently, but I felt we've got some like real code here and some things that we could do. So I figured I'd poke at this for a few minutes and give you guys kind of like a real live demo of where you might go with something like this. So in this case, I don't like this particular cell, the one at the top. So I'm going to go ahead and I'm going to ditch it. So I'll just use the cut and make that go. But maybe I want to have a new cell inside. I'm going to go ahead and move that one up, and we're going to put some markdown in here and say something like, this is my talk on Lambdas. How about this is Jeff's talk on Lambdas, right? And so that's just kind of straight up text. If you've ever used Markdown, you can do things like create headers or whatever. So you got to produce a report for your boss. You got to produce some sort of documentation on some of the data science or the analysis that you've been doing. And you want to produce all of the stuff in line. So, okay, now I've got a little bit of a header here, and I want to go in and maybe put a little bit of text. Okay, we'll go in, put a little bit of text. So this is all about Lambdas and more Lambdas, right? And I can't spell Lambdas today. Lambdas, right? So you can totally build the text of your report with multiple levels of headings, etc. If you need to have some sort of bullets and stuff in there, I think *C's will make you bullets. Might. All right. So you can say something like, lambdas, more lambdas, and even more lambdas, right? Lambdas. So you get that in there, and then you got your bullets, and people are ready. We come in here. We set some of our variables. If I want to execute that, I can. If I want to toggle off, like, hey, you know what? For purposes of displaying this to a class or to my boss, I don't need this intermediate value to show up, but I do want it to be stored someplace. So we can store it in a variable. We go in, we can make this nice thing. Jeff failed to properly docstring his function,
By the way, I never use doc strings. You made me notice. I didn't even know they were called doc strings. So as soon as you said it, I was like, yeah, that's a good call.
Yeah, so, we can go in and you can edit all this stuff on the fly, right? Let's call this one add to. So we have a little bit of a difference. We run add. Let me go in here and I want to make a quick copy of this and paste it because these two things are fairly similar. There we go. So you can edit your script kind of on the fly, all the typical things that you would want to do. You can make new. Yep, you can make graphs and charts. Sweet, awesome.
For anyone who's ever used R and R Markdown, this is the same thing.
Jupyter.
A report, you can build a demonstration, and if it's like R Markdown, I bet it is. You can basically export the whole thing as a web document, like as a HTML page. You can then post in your blog, and it's got your conversation plus your sample code plus the results and everything all in one file.
Oh my gosh, this looks amazing.
Exactly.
Oh, I want to do Markdown.
Yeah, Markdown is phenomenal. If you have a WordPress blog, install the Markdown module from Jetpack. JetBrains, Jetpack. Yeah, Jetpack Markdown. It allows you to type all your blogs in Markdown, which means any text editor becomes your HTML editor because you use shorthand for headings, for lists, for basically anything you do with HTML, you can Markdown in a very readable shorthand. Yeah, Markdown's phenomenal. I thought you already knew about Markdown. I thought using Jupyter, you use Markdown too.
No.
All right, so I'm pulling up a couple of notebooks that folks have made, right? So this guy, he produced some sort of introduction to probability. He threw in, well done. He threw in, images, right? Anything you can do with HTML, because you can drop HTML right into the cells. You're not limited to Markdown. You can use HTML and Markdown. But you can put links in here. So he's got a link to the Wikipedia article on, Pierre Simon. He's got links to various things, the outcomes, the experiment that he ran. He's got a variety of pieces of code and more pictures and blah, blah, blah. All right, so let's go look at this guy. This one, he used matplotlib to produce a graph. The graph is inline. If for whatever reason he needs to come back later and he needs to change the data a little bit, hey, I want to make this a 1,000 instead of 100, he can then re-execute the code and his graph will update in real time. And you could share this notebook with your boss. So instead of just producing a static report with an image, you can say, here, boss, here's the data. Here's the script I used to produce the data. Here's the graph that came from the script. And your boss looks at it and he goes, wow, this is pretty good, but I might want to project something. So let me, imagine that we had this result next quarter and change the numbers a little bit. And he could see how the graph changes kind of in real time. So
also another use case of this, and people at First Hawaiian Bank are doing this regularly. They have to do quarterly and annual reports on the modeling they're doing for these very large data sets. So they write the report once, and then every quarter they download the new data from the database and plug it into the report and push a button, and the report is regenerated with all the right graphs, all the right charts, all the right everything, but with different data.
and it takes however long it takes for, the R to run the report. So you just hand it a different data file and regenerate your report, and it's regenerated.
This guy's got some geo stuff. You can put cool tables in your data. So any of you folks who are doing intelligence analysis, data analysis, you're a geek in college, if you want to produce some sort of an output for your boss, your professor, etc., Jupyter notebooks are pretty slick. A great opportunity. And so I'm going through the Jupyter gallery here, and these are just different notebooks that people have produced, and you can see they're earmarked by day, right? Jillions of possible use cases for these things, and it just keeps loading. This guy's got some sort of random flow chart in there. Might have been automatically generated, might have been done in PowerPoint or something, I don't know. But lots of cool things. So October 29th, we're going to have Jupyter Day. We want you guys to be there. If you would like to give a talk on something cool that you do with a notebook, just let us know. If you go home and you're inspired and you're like, oh, I'm going to do my next class assignment in Jupyter Notebook, you can demo it. We'll have talk slots for 5-minute quick demos. Like, hey, I got this thing, it's cool. We'll have, hey, 30-minute slots for this is pretty slick and this is how you do it. And we'll have some, I think at least one tutorial slot for like a 2-hour-long tutorial. All right, sit down, bring out your laptops, load this, install this, let's go through it. So lots of options for you.
If I want to talk there, what do I do, Tom?
Well, we will have a call for paper go out, or call for papers go out, and you will have to fill out a call for papers proposal, much like we talked about today. And we will look at them, and we will judge them, and we will assess them, and we will try and help folks to figure out how to do what they do and see what we can select.
So an email will go out, got a blog post published on my computer, but we
Yeah.
also have a GitHub account, Jupyter PyHawaii, and once you're connected, you can create an issue or add your token in there as well. So we're going to use GitHub for managing from now until October 29th.
And it'll be here. Huh? Yes, ma'am. Jupyter Day, Hawaii, 2016. It's going to start at about noon, go till about 4 o'clock. We'll have a series of talks, typically about 25 minutes in length each. But again, we're going to have, I think, one room devoted to tutorials, longer theme conversations. And we'll have some 5-minute lightning talks at the end. There's going to be heavy poo-poos and refreshments, so you can come and get fed. And that's pretty much about it for the night. I'll talk to people about their stuff. I'm going to kill them.